Hi everyone, in this lecture you will learn how to find square root of a number. So the question is, given a number n, you want to output square root of n, right? So this is your input and output is under root of n. So for example, if I give you a number 10, then the output can be 3, and if you want the precision also, then it will be 3.162, right? So we will first focus on the integer part, then we will also focus on the precision part, right? This part. So let's begin. The approach that we are going to follow is a brute force approach, which means we are going to try many possibilities until we get the best answer, right? So for example, what you can do, you can start with a random guess, right? So you can say, okay, your answer is 0 and your number is n, which is 10. So you can check if 0 square is less than 10 or not. Then it is less, you can update your answer by 1. You can say, okay, let's go to 1 and check if this is less than 10. Then you go to 2 square, which is 4. You can check if it is less than 10, right? Less than or equal to, right? So you keep on incrementing until it is less than or equal to 10. So let's go to 3 square. Again, it is less than equal to 10. And now you will go to 4 square, right? So as you reach 4 square, you can see the answer is not less than equal to 10, right? Because 4 square is 16 and 16 we obviously know is greater than 10, which means the correct answer was the number that was generated one step backwards, right? So one step, you have to go one step back. So from 4 you go to 3, right? And you can keep a variable I which just stores all of these numbers, or you can keep a variable answer which stores your what is your current answer, right? So every time we are going to the next position, we are adding 1 to our current answer, right? So your final answer is going to be 3. So this is how we can generate the integer part. Similar approach we can follow for the precision part also, right? So once you know you have 3, you can say, okay, now I want to finalize what should be the first digit here, right? So this digit can take values in the range 0, 1, 2 up to 9, right? So 3 point something will be anything 3.0, 3.1, 3.8, 3.9, something like this, right? So you need to finalize what is the best digit for the this place, right? The first place after decimal, right? So what you can do is you can generate a number 3.0 and you can check if this square is less than equal to 10. Yes, it is. You generate a number 3.1 and you check if this is less than equal to 10. Yes, it is. So you keep on generating 3.2 and you check if it is less than equal to 10. So we know this is not less than equal to 10, so you go one step backward. So how do you go one step backward? In the same manner like you did previously, right? So the only difference that is coming here is, instead of having an increment of +1, now you're having an increment of +0.1, right? So every time you increase your answer by a factor of +0.1. And once you know 3.1 is the best number, you can now finalize the digit for the next place. So you can start with your answer 3.1, 3.10. You can check if it is less than equal to 10. You make it 3.11. You check if this is less than equal to 10. You go to 3.12 and so on, right? So you will repeat this until this digit is finalized. So you go to 3.16. It is less than equal to 10, so you go to 3.17. As you get 3.17, you know it is now greater than 10, right? So this number is greater than 10, so this is not true. So you go to one step back and you know your second digit after decimal is now 6. So if you want to calculate for the third place also, you will repeat the same process with a different value of increment, right? So here the increment was 0.01 and for the next time your increment would be 0.001, right? This is the value of increment that you're going to add to your answer once you finalize digit, and your increment will be reduced by 10, right? So you can see the value of increment is changing from 1, it becomes 0.1. As you go to next place it becomes 0.01. As you go to the next place it becomes 0.001. And if someone is saying you want to calculate your answer for p places, you need to update your increment p plus 1 number of times, because if I want my precision up to 3 places, here in this case you have 3 places, then you need to calculate your answer for actually 4 places. 1 place is before decimal and you have three places after decimal, right, after dot, and 1 place for the integer part. Okay, so let's implement the code for the integer part, and then we will also implement the code for the precision part, right? So let's see how we can write the same thing in the code. Okay, so let's say we have float answer, which is 0. We have let's say float increment, which is 1. And what we can do is okay, so we can say while answer square, answer into answer, is less than equal to the number n. So we have to take this number input from the user. So int n, scene n, and while this answer square is less than equal to n, what I'm going to do, I'm going to increment my answer. Answer equals to answer plus increment, right? And due to this condition, answer square is less than equal to n, I will always overshoot the value of n, right? So let's see what happens if n is 25, right? So if n is 25 and I do this thing while answer square is less than n, so I do answer plus equals to increment, which is 1 in this case, right? So answer is 0, right? So answer will take the value 0, it will take the value 1, it will go to 2, it will go to 3, it will go to 4, it will also go to 5, because 5 square is less than equal to 25, and finally my answer will become 6. But actually I want my answer should be 5 only, so I will go to one step, I will go one step back in this case, right? So what I can do is, after my while loop is finished, I can say okay, answer equal to answer minus increment. So this is how we go one step backwards. Okay, so let's try to run this code now. Okay, yes, so we can run this code now, and I run the code square root. So let me give input, let's say 25. Okay, we forgot to output our answer also, right? So you can do cout answer and l. So if I give input 25, I get the integer part, which is 5. If I give the input as if I give the input as 10, let's see, do we get 3 or not? Okay, so this works perfectly for the integer part. Now let's modify our code to get it working for the floating part also, right? So when you're going to work with the floating part, you also need to input the precision from the user, right? So let's input the precision, and in this case we just need to repeat this work. This is the work that we need to repeat p plus 1 number of times, right? So I can say for int times equal to 1 or times equal to 0 times less than equal to p times plus plus. How many times I want to repeat this work, that's what we are doing. And this cout answer will come after the loop. This will go after the loop. Okay, so what I'm doing is I'm just repeating this work p plus 1 number of times, and one modification that we have to make is after this work is done, you have to change your increment by dividing it by 10. So initially the increment was 1, next time this increment will be 0.1, right? So what does this loop? This finalizes the digit for the current place, right? The correct digit up to this point, and this line of code increment updates the increment for calculating for the next position. Okay, that's it. That's exactly what we have discussed in the notebook also, right? So this is what we are going to do, right? So once you finalize this digit, okay, once the while loop gets over, you go to this place and you go with the next place, and here the value of increment is reduced by a vector of 10, right? Okay. So let's build this code now and try to run it. So if I give 10 and 3 as input, I get the answer as 3.162. If I give, let's say, 25 and 2, I get 5 because it's a perfect square. If I give 110 and 3, so I get 10.488, which means our code is correct, right? So if you have even little bit of doubt, I suggest you to just dry run this code on your notebook and things will be clear to you. Thanks a lot. See you guys in the next video.